Okay, so we're going to start with some geometric probability, and specifically what we're dealing with here is after this, you should be able to identify if a problem is geometric or is it a binomial, or is it neither. Lastly, be able to correctly calculate geometric probability using a TI-84 calculator 3 out of 4 times. So, and actually should be able to do it more than that. Let's go ahead and try this. So, our first thing is, what is a geometric probability? Well, before we've done a binomial, if you remember in a binomial probability, we were trying to say, how many times did we have a success? In a geometric, we're now going to ask, when do we have success? And usually, it's our first success, but when do we have success? And we're going to define what success is for each question. Now, in order to be a geometric, it's kind of like a binomial. You have to have some of the same things. First thing is, each outcome results in success or failure. There's only 2 options. They have to be disjoint, just like in a binomial. Number 2, trials have to be independent from each other. That's just like in a binomial. Number 3, the probability of success remains the same between trials. I can't have a chance of success that's fluctuating or moving around. That's just like in a binomial. But in this one, the variable that we're figuring out, it's the number of trials before the first success. This is where we're different. Remember, in a binomial, we had a fixed number of trials. In a geometric, we don't necessarily have a fixed number of trials. We're trying to find out how many trials to get to that success. So let's figure out if one of these is a which or which. So number 1, I want to know, is this a binomial, is it a geometric, or is it neither? And number 1, the probability of getting between a 6 and 8 baseball prediction is correct if I have a 45 to 65% chance of guessing each one correctly. Well, the first thing is, nowhere in 1 is it asking me about when do I first get one correct. In fact, it talks about getting between 6 to 8. Getting between 6 to 8 correctly. That's like a number of successes. That sounds like a binomial. But to be a binomial, I have to have a fixed number of trials. And if I look, I don't really have a fixed number of trials. I might try and imply, well, there's 8 trials. Maybe there is. So I'll keep going from there. I need to have trials be independent. Predictions, sure, they're going to be independent from each other. My predictions would be independent. One prediction doesn't change another. I need to have disjoint. Well, a prediction is correct or it's incorrect, so that's okay. But then I need a fixed probability. This is not fixed. Sometimes it's 45%, sometimes it's 60%. That's not fixed. If it's not a fixed, it can't be a binomial. It can't be a geometric. So this is neither. It's not a binomial or a geometric. I don't have that fixed probability. So number 2. I'm pulling cards from a deck of cards. I'm shuffling between picks. So I'm putting all the cards back in and shuffling them. And I want to know the chances you'll pull the king of diamonds for the first time on a particular draw. I mean, we could say on the 8th draw. Okay? Just a particular draw. If I look, it tells me right now, I'm looking for that first time. The first time something happens. That sounds like a geometric. I'm talking about when success happens. Okay? That's a geometric. Well, it says a king of diamonds. Well, chance of getting a king of diamonds is just 1 out of 52. And it's always 1 out of 52, provided I'm putting all the cards back in the deck. And I'm shuffling between picks. I'm putting all the cards back in the deck. So my chance is going to be the same. 1 card to a next, 1 draw, shuffle, another draw. Those are independent, so I do have independence. And these are disjoint. Either got the king of diamonds or I didn't. Okay, the only thing I didn't see, nowhere in here we see a fixed number of trials. So I shouldn't have even been thinking binomial because I require that. But I was talking about a geometric. So this is a geometric. It meets our 4 conditions to be a geometric. Okay. So I got one more. Flipping coins with some old guy who rambles on about probability. You want to know the probability that both of you will have matching heads, which happens 25% of the time. What it means is you're flipping a coin at the same time they're flipping a coin. You'll both get heads 25% of the time. Now I want to know what happens on 9 or less times out of 30 flips. Well, that out of 30 flips, that's a number of trials. I'm only doing 30 flips. I have a chance of success. It's 0.25. And I know it's independent. Flipping coins, then flip it again, they're independent. We either both get heads or we don't both get heads. That's disjoint. I only have two outcomes. I have success or failure. And I'm doing it for a certain number. I want to know about 9 or less times. 9 or less. So that's how many successes, 9 or less. This is a binomial, just like the binomials we've already done. So this one is a binomial. All right, so we want to be able to tell those apart, because once we can tell them apart, now we know how we're going to solve them. Okay. So let's say I'm rolling a 6-sided die. What's the chance of getting a 3? Well, we've talked about this before. There's 1 3 on the dice out of 6 sides. So on a geometric, what we're saying is the first success. So what about rolling a 3 for the first time on the third roll? Well, then I had to get that 3 on the third roll. So I got 3 rolls here. I got my 3. But now look at my first 2 times. Well, if the first time I got a 3 was there, that doesn't tell me anything about the rest of the times. I could have gotten anything except a 3. So that's 5 out of 6 over 5 out of 6. And if we remember, I'm doing multiple events. They're independent from each other. So I just multiply them all times each other to find our real probability. And we're going to end up with 25 out of 6 times 6 times 6. Or 6 cubed. 216. So 25 out of 216. And we put that in a calculator, we're going to find it's approximately 0.1157. Now the nice thing is the calculator gives us an automated way to do this. And I'll put this higher on the screen so it's easier to see. Okay. We can use the geometric PDF. And it's a probability distribution function. But specifically, we've been saying, and we've said it before, that P means precisely as a way to remember this. We want to know about getting that 3 on the third try. So we want our first success to be a 3. And our probability of success we said was 1 out of 6. So let's try it out. We pull up our calculator. We hit second vars. We go and we find geometric PDF. And if we go up to find it, we'll find it a lot faster. So there's my geometric PDF. It asked me for my P. We said that's 1 out of 6. So it's 1 divided by 6. My X value, that's the success. We said that's 3. Our first success happened on the third try. And it tells us 0.1157. And we found that manually. Without using a calculator, we'd already knew that's what it should have been. Then we also have, our geometric CDF. Just like our binomial CDF, we use this to calculate the probability for success when it happens within some group. Okay? And what it's going to do, it's going to add up all of our individual PDFs until it gets to the number that we tell it to stop at. Whatever we put in there for our geometric CDF for our X value is going to be when we're telling it to stop. When we think about this, and just generally how we solve these, we know we're going to write these numbers on paper. And we put this dot, dot, dot because there's really no fixed number of trials. It could keep going forever. And here I want to know what's probability of success first occurs in the first 5 trials. So see where our numbers, I've got 0 through 10 here, but really I can't have success on the 0 trial. There's no such thing. I actually have to try it at least once. And I want success in the first 5. So that's going to be in our first 5. I've circled more than one number. Like I said, circle, I go to CDF. So it's going to be a geometric because we're looking for our first success. We circled some numbers. I'm going to tell it the chance of success, in this case 5. That's when I want to stop. I want to stop on the 5th trial. So now what's probability of success first occurs after 5 trials? Well, it can't be the 1st, 2nd, 3rd, or 4th. The 5th isn't after the 5th, so it has to be sometime after the 5th. So sometime up here. So I didn't start at the very beginning. I didn't start with 1, so I know I'm going to have some subtraction. The only question is, what am I going to subtract from what? If I look, I didn't close this circle. It just went on forever. I'm going to the end, so to speak. So we do 1. So I'm doing 1 minus, because if I look at this, I also could say this is at least the 6th trial or later. At least would tell me 1 minus. So I want to remove what I don't want. What I don't want are these first 5. So I don't want the geometric CDF, because it's more than one of them, whatever my chance of success was, and the largest number I didn't circle, 5. I don't want it. I'm removing these individual possibilities from the overall group. So I'll be left with the actual answer. Let me try again. One more here. Was a probability of success first occurs between the 9th and 8th trial inclusive? So it means including the 4th and 8th. So I know I'm getting 5, 6, 7. It includes 8 and it includes 4. This is a case where we said we didn't circle all the numbers. We didn't start at the very beginning. So I know I'm going to have some subtraction. But I figure out what to subtract. And normally we do these. We always subtract the smaller number from the larger. So I want to do my larger first. So my geometric CDF, the largest number I circled was an 8. So my chance of success, and then 8. And then what do I want to remove from that? If remember, we're removing what we didn't circle. I didn't circle 1, 2, or 3. So I'm going to remove a CDF, whatever my chance of success was. We didn't deal with 1 here. I'm removing 3, the largest number I didn't circle. So when that's done, it's going to leave me. It's going to leave me with 4, 5, 6, 7, and 8 already added up for me. So let's actually try a couple of these now. And again, second VAR's geometric CDF. So let's say we have 8 out of 14 students play Mario Kart. So in a random poll of students, what's the probability the 6th student I ask is the first student who plays the game? Well, my 6th student plays. The chance of them playing, I need to know my chance of someone playing. So the chance someone plays, well, that's equal to the probability someone plays. Well, it's 8 out of 14. 8 out of 14 students play. And in this case, I want to know what's probably the 6th is the 1. So I'm really looking for x is exactly 6. So I know this is going to be a geometric, and it's going to be a PDF. I want exactly 6. My probability is 8 out of 14.